Hi, this is Mr. Miller, and in this video, we're going to talk about rational functions and wholes. We've seen that rational functions can have vertical asymptotes and horizontal asymptotes, but they can also have points where the function is not defined and there's a little hole in the graph. Okay, here's our first example. We have a rational function here, and we see that both the numerator and the denominator have this factor of x minus 2. They have a common factor. And if we canceled it, we would end up with this much simpler function. Well, there's one key difference between these two functions. This original function is undefined at 2. Everywhere else it's the same as this one. But when x equals 2, this one would be 4 times 2 minus 2 over 2 minus 2 times 2 plus 5, which is 0 over 0, which is undefined. So at 2, this graph has a little hole in it where it's not defined. It's completely identical to this graph, which is defined at 2, except at that point, all right? So at 2, this one exists. It's actually 4 over 2 plus 5, which is 4/7. So this function has a hole where this function has a point there. Okay, let's take a look at our second example. Here, the repeated factor is x plus 1 over x plus 1. And this function is completely identical to this, except at -1, where this has a hole, and this one at -1 doesn't. It has a point there that belongs to the graph. So when these factors cancel like that, there's just a hole. All right. On this one's a little bit different. We can cancel a factor of x minus 5. We can divide the numerator by that and one of those here, and we end up with 2 times x minus 1 over x minus 5, which is what I have here. This time, a factor of the repeated factor remains in the denominator. And it turns out these graphs are the same. There's no hole this time. This one has a vertical asymptote at 5, which is about right here. So the simplified function's undefined at 5, and it turns out, well, so is this one. This one's going to have an asymptote also. So when the factors cancel but some remain in the denominator, like here, the x minus 5 remained in the denominator, they're both going to have a vertical asymptote. These functions are identical. So here's a rule to tell when we're going to have a hole or not. If the common factor completely cancels or remains in the numerator, then there's a hole. So here we see these completely cancel, and this is a case where there's going to be a hole in the graph. Everywhere except at 4, this is going to be equal to 3 times x plus 2 over x minus 5. On this one, the other case is that when the common factor remains in the denominator. Here, if we cancel an x plus 1, we're left with 6 over x plus 1. The common factor remains in the denominator, and it's still going to be where a vertical asymptote is. Okay, I want to do one example from the assignment. The first step is to factor the numerator and the denominator so we can see if they have any common factors. You can use Wolfram Alpha for this if you want it to factor for you. But this one's going to factor into x plus 7 times x minus 2. And this one's going to factor into x plus 7 over x minus 3. So we see we have the repeated factor here. This is going to equal to x minus 2 over x minus 3 everywhere except at x equals -7, right, where this repeated factor cancels. Okay, well, to find the domain, we know that the denominator determines that. The domain is going to go from -infinity to -7, where there's a hole in the graph, union -7 to 3, where there's a vertical asymptote, union 3 to infinity. Because of the vertical asymptote in the hole, this graph is going to have three pieces. This function does have a hole. It has a repeated factor, and that hole is going to occur at -7. And when I put -7 into this, I can actually figure out where that hole would be. If I put -7 into this, we're going to get -9 over -10, which is 9/10. So, okay. This function has a point there. This one's going to have a hole there. So at -7 and a little bit less than 1, we're going to have a kind of hole in the graph there. Well, this one is where the hole is. X equals 2 is going to be where a 0 is. That corresponds to the other factor in the numerator. So there's a 0 at x equals 2. Vertical asymptotes, well, this is where the hole is. This is where the asymptote is. So we're going to have a vertical asymptote at x equals 3. Okay, well, does the function have a horizontal asymptote? Yeah, if we look at the ratio of the leading terms, we see that the function for large x is about x squared over x squared, which equals 1. So the horizontal asymptote is going to be y equals 1. We can use Desmos to sketch the function. I'm going to do the best I can here. This function is going to come down like this and approach the asymptotes that way. Okay, and it's going to come up from -infinity here, go through that 0. My graph is really wiggly. Go through that hole and go that way. All right, that was pretty bad. But if you smooth this out, you get an idea of the graph. So it's very much like what we've been doing, except we have this new feature. There's a hole in the graph which corresponds to the repeated factors. All right, well, we'll be doing a bunch more examples of this, and it'll become easy for you. Take care.